I was on a call with a colleague this morning on some deliverables I needed to get out of her this weekend. We always have work to do. And while on the call she mentioned that she was trying to cook and requested that I indulge her while she peels and fries her plantain. As the call progressed, all of a sudden I heard her shriek, and then the line abruptly went off. I was distressed and instantly called her back. Again and again, I called but she didn't pick up. I blamed myself and wished nothing bad happened to her. Connect with me via WhatsApp, +234 703 247 4726, to get more interesting videos. Some minutes later, I saw her name on my phone screen. I don't allow my phone to ring for concentration reasons, and hurriedly picked it up. I asked what happened and she narrated how oil had splashed on her as soon as she poured the plantain inside the frying pan. Luckily, it wasn't much, and that's the only reason she still had the presence of mind to call me back. Then she said, "I know you know everything. Can you explain what caused it? I know what I did to make this happen, but what is the scientific explanation?" I rubbed my palms with glee and got into my teaching mode. Most of the occurrences in our natural world have explanations, and this is one of them. This starts with the word density. In physics, density refers to how much an object weighs in a given volume. Take two 10-liter kegs and fill one with water and the other with sand. The keg with sand will be heavier than the keg with water. Even though they are both of the same size, the keg of sand is heavier because sand is more dense than water. Density refers to how tightly packed molecules of substances are, and also how heavy the atoms that make up those molecules are. For instance, in looking at water and oil, like it applies to my colleague, water is more dense than oil. This is for two reasons. A. Water molecules are small and packed tightly together, while oil molecules are much larger and don't pack as much. B. Water is made up of oxygen and hydrogen atoms, while oil is made up of carbon and hydrogen. Oxygen is heavier than carbon. Putting these two together is the reason oil floats on water when they get in contact. The heavier atoms of water sink to the bottom while the light atoms of oil come to the top. Oil is less dense. How do you make water less dense than oil? You boil. Boiling water turns it into steam, which occupies as much as 1700% of the volume of the same number of water molecules. In other words, for the same molecules of water you have in one keg of water, you would need 17 kegs. How does this happen? Heat breaks up the molecules. That sound you hear when you boil water in a kettle is the sound of molecules of the gas escaping. The heat causes the molecules to expand with so much force that if your hand or body stands in the way, it could hurt you badly. Can't you hear that whistle it makes as it escapes? Now, back to our plantain. Studies show that plantain is made up of 61% water. Banana has 75%. So a plantain in oil is 61% water in oil. When you boil water, it reaches 100 degrees Celsius. That's much hotter than our body temperature of 37 degrees Celsius but lower than boiling oil, which is 175 degrees Celsius. So when water touches boiling oil, which is at 175 degrees, it instantly reaches its own boiling point of 100 degrees and turns into steam. Remember that boiling makes water molecules expand as much as 1700%. And because it is so sudden, it needs to expand very, very quickly. Therefore, when you pour that plantain into hot oil, the water in the plantain comes in contact with the hot oil and it quickly turns into steam. The steam needs to escape very, very quickly. It is at the point of escape that it can cause harm. So you have to make sure you stand back as much as possible so the steam can have enough room to escape. One of the worst things you can do is pour ice plantain into hot oil. I have heard of cases where this has led to the burning of houses when done indoors. Here is how it happens. Ice poured into hot oil quickly falls to the bottom of the pot. It is less dense. but because it is absorbing heat quickly, it will quickly change to water and then to steam. The expansion of the volume of the molecules in these three phases, solid, ice, liquid and gas, is so sudden that the steam explosively pushes the boiling oil out of the way, beyond the pot. If the boiling oil gets in contact with the fire source, gas cooker or kerosene stove, it catches fire and then quickly ignites the oil molecules close to this. This happens in an instant, but if you watch in slow motion, you will see exactly how the fire spreads and then becomes raging. A few lessons from this. A. Avoid pouring ice substances into boiling oil. Let them thaw. Thaw means allowing frozen substances to become liquid. B. Use as flat a frying pan as possible so the steam escapes as freely as possible. C. Boiling oil comes with its own hazards, so you have to be safety conscious, which includes concentrating as much as possible to avoid injuries. It has to be said that avoiding phone calls in the kitchen is one of them. The power of distraction from phone calls is underrated. Physics is fun. The basics of physics can be understood by everyone because we observe them daily.